Hello everyone, welcome to our senior design project. My name is Kai Yang from Group 1, 1 GHz. Our topic is design and build a 1 GHz sine wave generator. Rick Hunter is our advisor, and there are 4 people in our groups: Ding Su, Kai Yang, Zhao Xiangzhang, Zhibin Ye. And we are all majoring in electrical engineering. Then let's start. This presentation is divided into 5 main parts: introduction, hardware design, software design, effect demonstration, and other suggestion and analysis. For this project, signal generator is one of the best tools for electrical engineer. Sine wave circuit is widely used, and high-frequency signal synthesis technology is developing rapidly. So this topic is meaningful. After talking with our professor, we decided to apply the combination of PLL and DDS. The proposed solution is also conveyed in this slide. Move on the second part, hardware design. This flowchart is the overall flowchart of our hardware part. We will need study the control module, DDS module, clock module, and power module. As for the DDS module, DDS means Direct Digital Synthesizer. Figure 1 shows its principal diagram. From it, we could see that the input signal is going through the ROM and to convert into a discrete signal. And after going through this block, which is DAC, then it converted into a continuous signal, and then after filtering, the output signal is designed. After talking with our advisor, we finally decided to choose AD9814 to achieve the DDS function. Figure 2 shows its block diagram. And based on its datasheet, we find it could output 1.4 GHz signal at most, which could meet the requirements. In addition, AD9914 works at the single frequency mode and the serial ports for data transmission. Figure 3 is the DDS schematic circuit designed by us using AD, Altium Designer. And Figure 4 shows the DDS in demo board circuit. It just connects the pins in parallel, which will connect with the same voltage level. And compare these 2 circuits, we could find they are roughly the same, which also could be proof that our design circuit is suitable.
Hello, I'm Zhao Xiangzhang. It's my turn. The clock module is the driving force that enables the system to work normally. At the beginning, we designed to use the internal PLL of AD9914 chip to generate the system clock. After punching the demo board, we find it generates the system clock using ADF4350 chip, which reaches to the same effect. As for ADF4350 chip, the frequency source designed with the ADF4350 has the advantages of high output frequency, stability, and so on, just as shown in the PPT. In addition, its output power can be easily programmed. As for power module, the difference between designed current and demo board current is that only the model of no dropout regulator has changed. Both of them can regulate the output voltage even when the supply voltage is very close to the output voltage. Now we can see that terminal of the chip will be connected in parallel with large capacitors and small capacitors. Large capacitors filter no frequency interference, and small capacitor filter high frequency interference.
Hello everyone, my name is Zhibin. At the beginning, I will introduce you about the control module. In this module, we use STM32F401 as a core chip. It is a useful microcontroller based on Cortex-M4. It mainly adopts NVM and ALT technologies. Here are mainly two strengths of this chip. First, it has good balance between power consumption and performance. Second, it is high integration chip. And here is the block diagram of this chip. Now let's focus on software design. Here is a flow chart. And we first do some initiating jobs in the control module, the DDS module, and some peripherals. And then we control registers to set desired output, and then we get 1 GHz sine wave output. Here is a problem we face with in this senior design. We first choose CY7C68013A as the core of the control module. However, after researching, we found that the learning material of this chip is limited, and also the surrounding circuit is hard to replicate. And materials for coding in STM series are open source online. So finally, we changed it to the STM32F401 in experimenting and coding process. Let's come to the demonstration results. We use the device to generate 200 megahertz, 500 megahertz, and 1 GHz. And it turns that in 1 GHz, due to the limitation of the scale, there are too many fluctuations.
Hi, I'm Ding Su. At present, we can only get sine signals, and other types of signals can be considered in the future work, such as square wave, triangle wave, and so on. Besides, we want to build a friendly human computer interaction interface. For example, we can use touchscreen or use host computer software to set the signal's parameter. This avoids the need of loading the code every time when the parameter is updated, which is convenient and time-saving. About timeline, in September we read the related literature, communicated with our advisor, and finally decided to use AD9914 as a solution. In October and November, the system design block diagram was abundant, which mainly includes DDS module, control module, clock module, and power module. We designed the circuit for these modulars. This year, in February, we purchased a demo board which already contained some modulars such as the power module and the clock module. We compared and analyzed the designed circuit and the demo board circuit. In addition, we redrew the demo board circuits. In March, we wrote the code after understanding the control principle and improved the code through testing. Finally, we used an oscilloscope to measure the output signal of the demo board and organized all the documents of the project. Now we are writing the final report, and these are references. That's all. Thank you.